Okay, so we will explain now the AR function, autoreclosure function in ABB REX650 relay. So from the parameter setting here, the AR is on, and the reclaim time is 700 milliseconds, and the first reclose time, which is the dead time, is 600 milliseconds. This is our setting right now. You can see it from here. So we activate setting group 1 to able to test this kind of application. So in the same file, we did it yesterday. Just we will minimize the backup over current, and then we will start with the auto reclosure. Okay, so we have two types of auto reclosure, and there is some condition also for initiating and blocking the AR function. So the AR function to be worked as expected, you need the circuit breaker to be ready, which means the circuit breaker spring is charged and the circuit breaker status is clear, it's closed, then it will be open to able to check the dead time, and also synchro check for the line between the bus bar and the line voltage transformer, and many conditions for enabling the AR application. Also the initiation of the AR, it's coming from the fast tripping functions like zone 1 tripping or differential tripping. So the instantaneous tripping initiating the auto reclosure, because the protection relay will make first reclose attempt in case if you have any transient fault and there is no any fault anyway anymore. So the circuit breaker will be closed healthy to mitigate the interruption of the power supply, the interruption time of the power supply. Okay. Otherwise, if the protection tripped again, or tripped in the first time by delayed protection function like Z2 or overcurrent protection, so the AR is blocked and it's not initiated, because this is a sustained fault, which means the protection relay takes a lot of time to assess this delayed trip. So there is no way this is a transient fault. If it's transient, it will not reach to the tripping stage. Okay, so this is the sense and the logic of the AR. Okay, so we will explain. From the test universe, we have dedicated test module called the AR. So if you are inserting a test module, you will find there is auto reclosure dedicated module. Normally, you can do it also using the test sequencer, but you have to simulate the pre-fault case, and then the fault case for the circuit breaker tripping by instantaneous tripping, instantaneous function. Then you have to simulate the third state that the circuit breaker is open and waiting for the first reclose attempt. And then you can simulate also a second, fourth state for simulating that the circuit breaker is on and healthy, which means that it was a successful attention for AR. Okay, so we will open this auto reclosure. As you can see, I will explain here. Here is the shot and times. Here you have to define the fault type and the fault type and the impedance on the impedance plane. So if you have impedance plane like this, you can choose first tripping, fast tripping, or delayed tripping to check the successful and unsuccessful of the AR function. Then you can specify by the cursor, or you can specify using this fields for line to ground, line to line, and three line, and the impedance in respect to referring to the line length and the angle and the constant test current, because we choose the Z impedance percentage at I constant or constant current source. Then you have to specify also the duration of the pre-fault and the time limits during the test. We have different tips. The first one is the unsuccessful sequence. The unsuccessful sequence, it will simulate a trip. Then it will simulate, it will get a reclose time, which is the dead time, and it will simulate another trip to reach to the AR block or unsuccessful reclosure. Okay, so here you can enable the test if you need to assess this values. If you don't need, you can deactivate this field. Or if you need to assess the dead time and the tripping time and so on, you can enable this unsuccessful test. Okay, then you have to specify here how many number of shots. So I have one. How many number of shots? I have 1 or 2. So you can do it from here. Okay. So I have only one shot. So after this shot, if the circuit breaker tripped, the AR will be blocked and it will be considered as unsuccessful reclosure. Okay. So first event here, I will assess the trip time in the beginning, the first trip time. Okay. And here is the assess mode. You have different options. You can record this time only without any assessment, pass or fail. You can make it expected to be tripped or not expected to be tripped, and so on. So I check the time and I give it the nominal is instantaneous tripping, which is 30 milliseconds, to assess this time with the deviation plus or minus tolerance deviation plus or minus 50 milliseconds. Okay. Then I have also a dead time. This dead time, I will measure the time and assess this time, which is 600 milliseconds based on the parameter setting. Okay, and the tolerance also plus or minus 50 milliseconds. The third event here, the second 3-pole tripping for the second trip time, which is the delayed trip time in Z2. Okay, Z2 is expected to be 400 milliseconds with tolerance also 50 milliseconds. Then the fourth event is the circuit breaker close, and after that it's not expected because AR will be plugged in the third stage here, so it's not expected to have a circuit breaker close, and it will be assessed here. Okay, here is the unsuccessful sequence. We have also a successful sequence which will stop until the 3-pole tripping only. Okay, so it will measure the trip time, first trip time, instantaneous tripping time, and it will measure the dead time for the first reclosure attempt, which is 600 milliseconds, and then the 3-pole trip is not expected because this one is successful. Okay, so you can simulate successful sequence, or you can simulate unsuccessful sequence, or you can simulate both of them in the same file. Okay, so this for unsuccessful, I can keep it for unsuccessful only, just to give you what is the difference between both. Okay, and there is the assessment setting. So the dead time will be initiated from the trip signal up to the close common changing from 0 to 1. Okay, here is the dead time. Okay, and then the circuit breaker close time also will be assessed from the close common from 0 to 1 up to the close common from 1 to 0. This is the CB close common duration. Also, the trip will be assessed, will be started from the fault inception up to the trip contact changing from 0 to 1. Okay, and many more, trip L1, trip L2, trip L3, but it's in red now because this trip L1 and trip L2 and trip L3 is not configured in my hardware configuration, and you can see this. Notice here some events marked with red color are not available because the signals are not configured. But if you are configuring trip L1, trip L2, trip L3 in the hardware configuration, it will be detected automatically. But for now, I am only configuring the start and the trip and the close common. Clear? So for this test, we will do only unsuccessful sequence. And please check this simulator box. Now the circuit breaker is closed.
Yes.
Okay, and circuit breaker is ready and should be ready in the beginning before starting the test. Okay, yes. Ready means the circuit breaker spring is charged and the trip circuit is healthy and no any issue of the circuit breaker. Yes. Okay, so I will start the simulation now. You can see the indication of the circuit breaker. Now circuit breaker is tripped and closed, and then tripped and steady and blocked. They are blocked and it's still not closed. So if you can see here, the trip time is 30 milliseconds, now 63 milliseconds. The dead time is 600 milliseconds, now 599.9 milliseconds, which is very accurate. And the circuit and the 3-pole trip time, which is the zone 2 trip time, is 427 milliseconds. And the circuit breaker is not expected to be closed again. Yes, it's not closed, so this assessed as both. We have some simulation to make switch off of the circuit breaker ready before the final cycle, just to check what is the response of the protection relay, and the AR close command should be not issued at that time. And also you can switch off the sync release before the final cycle. Okay, we can go also for the successful. So here we will disable the unsuccessful event, and you will see the difference in the circuit breaker itself, circuit breaker indication. So for this test, the unsuccessful is deactivated. I don't need to assess, but I need to assess the successful test. Okay, and please be careful that any thing here in the successful sequence assessment, you have to put it here also. Okay, so there is no way to edit here in the successful. But if you need to edit this one, you have to edit it from the unsuccessful, even if you are disabling the unsuccessful test. You have to specify it from here. Automatically it will be, yes, if I make it record only, yeah, it will be automatic affecting. Okay, it will be automatic affecting the successful sequence. Okay, so for this test, I disable the unsuccessful sequence and I will enable the successful sequence. And here is the trip, and then first reclose after dead time, and then the second trip is not expected. So there is no any second trip, and you can see the effect here in the circuit breaker indication. circuit breaker now is closed and ready. Then trip, then close. That's it. There is no second trip, which means this successful reclosure. Okay, here is the first trip, and here is the dead time of the first reclosure.
Yes.
And here you can see the assessment and the report view. Okay, for the first stage, for the dead time, and for the trip, and so on. So you can define also this report view from here, and you can allow the test result to be shown because it was not shown here in the report view. Now you can see here the start and the trip command, and after sometimes which is the dead time, the first reclose here in the time signal view, and here is the assessment of this test result. Clear?
Yeah.
So, can we do both together? Yeah,
Yes.
we can do both together.
Yeah.
But the fact it will finish the successful scenario, then it will give a second trip for the unsuccessful scenario. Okay, so we can enable both in the same test module. Yeah, now this one is enabled, and the successful I will do it enabled also. But here is the 3 event, and here is 4 event, including the second. Yeah, unsuccessful. Now circuit breaker close and ready. Trip, close again after first shot.
Yeah.
Now, okay. So you can see the both assessment in the same module. Last shot for the unsuccessful. Yeah, it will take it for the assessment of the unsuccessful scenario. Okay. So it will make successful and then unsuccessful. It will end with the unsuccessful event.
Yes.
Because if it starts with the unsuccessful, it will be blocked. So there is no way to start the successful. Yeah. Okay. Clear?